In this lesson, we are going to look at atomic mass units in more detail. Before we go any further, you will need to be familiar with the parts of an atom and the terms used, in particular, the mass number. You may also wish to refer to our lesson on radioactive isotopes. As a quick reminder, here is a helium atom. It has 2 protons and 2 neutrons in the nucleus. This gives it a mass number of 4. This actually means it has an atomic mass or relative isotopic mass of 4. But 4 what? The clue is in the name, relative isotopic mass. It is a unit of measurement that is based on a comparison to something or in relation to something else. That something else is a neutral, unbound carbon-12 atom. Scientists had previously attempted to use hydrogen and later oxygen-16 as a reference, but as heavier elements and new isotopes were discovered, it resulted in physicists and chemists disagreeing on masses. In 1961, scientists eventually agreed that a carbon atom, or to give it its full and correct name, a carbon-12 atom, has a mass of exactly 12, making it the accepted reference atom. In fact, the mass of a carbon-12 atom is so exact and well agreed that it is sometimes written to 4 decimal places. Therefore, one atomic mass unit, or AMU, is quite simply 1/12 of the mass of a carbon-12 atom. Every atom has its own unique atomic mass based on this relative scale. Our earlier example of helium had an atomic mass of 4. In full, this means that the helium atom has a mass of 4 times 1/12 of the mass of a carbon-12 atom. Of course, it's far easier to write this as 4. Following this rule, a hydrogen atom has a relative isotopic mass of 1, and a fluorine atom has a relative mass of 19. Now it's your turn. What about nitrogen? Here's the atom. Now pause the video whilst you work it out. All we need to do is look up the mass number for nitrogen. It is 14, which means the relative isotopic mass of the nitrogen atom is 14. And that's it. Now, some of you may have noticed that not all atomic masses on the periodic table are whole numbers. We'll be covering these in our lesson, Why Aren't All Atomic Masses Whole Numbers? But from this lesson, you need to remember one atomic mass unit is 1/12 of the mass of a carbon-12 atom, and we can use this to work out the relative mass of a particular atom.